So here we are going to look at picking a u because we do not have any simplification. We don't have an integral rule, so we got to pick a u. And you know, if there's ever a toss-up, I said like pick the denominator. But you guys, if you pick the denominator, it is not going to get rid of this natural log situation because you'll just have negative 1 dt. So we're not going to pick the denominator. And the key thing to kind of think about is like you want the more complicated thing. So in this case, I usually pick the exponent. So I'm going to pick the exponent because again, if I were to pick the denominator, that would not pan out. But you might have to play around with it to kind of see what happens here. So denominator is not producing a viable u for us. So let's look at the exponent, and that's natural log of 1 minus t. So our du, remember that natural log has that rule for derivatives, that it's the derivative of the argument over the argument. So the argument here is 1 minus t. The derivative of that is negative 1. And then we have our dt. All right, so let's see if we can make this happen because it does kind of look promising. I mean, we have a 1 minus t in the denominator here. All right, so let's just start with making the substitution based off of u. So based off of u, all this natural log 1 minus t business would become u. So this would become integral e to the u, but we would still have, based off of just u, we would have 1 minus t dt, okay? Then if we look at our du definition, we have the 1 minus t, we have the dt, we do not have the negative 1. So we would multiply in by a negative 1, and of course that means that we have to multiply or divide on the outside by a negative 1. So when we do that, this negative 1 over 1 minus t dt, all of that is going to collapse down by this definition of du to just du. And we will have e to the u and the negative. Okay, so at this point, our integral is completely in terms of u. So now we are ready to integrate. So e to the u is just e to the u. This negative tags along. So we'll have negative e to the u. No bounds here, so that means we have a plus c. All right, so once we integrate, then we substitute back. So we're back in terms of our original variable. So we had that u was defined as natural log 1 minus t. So that's what we're going to plug in. And that is our final answer, but it's not really our final answer. Now, it's not our final answer because remember that e and natural log, those guys undo each other. So this is going to become negative. These guys are going to eat each other, and you're going to have 1 minus t quantity plus c. Now, if you look in the back of the book or whatever, you might not see that as the answer. Here is what happens. You can distribute this, and you have negative 1 plus t plus c. And then you can combine this negative 1 with this c as one arbitrary constant. Because if you take an arbitrary constant and subtract 1, you're still going to have an arbitrary constant. So again, if you take the arbitrary constant, add the negative 1, that's still an arbitrary constant. So the idea is to combine negative 1 plus c as just one big, gigantic arbitrary constant, and then say that the function part of it is t. So that could integrate as t plus c. But this little trick of combining everything as one arbitrary constant, that is a trick. I'm not going to ask too much about that on the test, but it's good to be aware of course. Okay?